Now that we have covered the basic architecture of BigQuery, let's look at how you actually get your data into the system. There are several ingestion paths depending on whether you want a manual approach, a programmatic one, or a fully automated pipeline. The most common entry point is the console, which provides a graphical interface for one-off tasks. You use this for local uploads from your machine or to pull from storage services like Cloud Storage, Google Drive, and Bigtable. It also supports external cloud sources like Azure Blob Storage and AWS S3. The console supports a specific set of file types, including CSV, JSON-L, Avro, Parquet, and ORC. This is usually the go-to method for smaller datasets or when you are just starting to explore a new data source. For more advanced workflows, you can use the bqload command. This utility allows you to upload local files directly from your terminal. Using the command line is generally faster for repetitive tasks and large data operations compared to manual uploads through the browser. It is easily scriptable, making it a better fit for developers who need to automate parts of their data loading process. If you need to handle high-velocity data, the BigQuery Storage Write API is the preferred method. It is a powerful tool because it combines batch and streaming ingestion into a single interface. This API is designed for high-performance reliability because it guarantees exactly once delivery. This means you don't have to worry about duplicate records or missing data during the ingestion process, even at massive scale. For managing external sources without writing custom code, there is the BigQuery Data Transfer Service. This is a fully managed solution that automates data ingestion on a scheduled basis. It natively connects to Google services like Google Ads and YouTube, SaaS applications like Salesforce, and other cloud providers. This simplifies the process of keeping your BigQuery datasets synchronized with your business applications. And beyond these direct methods, BigQuery integrates with other GCP services to handle more complex pipelines. For instance, you might use DataStream for continuous ingestion or Dataflow for batch or stream processing. You could also utilize the managed service for Apache Spark for Spark jobs, PubSub for real-time messaging, or Data Fusion for visual pipeline building. Now, a specific ingestion requirement that could show up on the exam includes CDC and replication into BigQuery from another database. The goal of this approach is to keep BigQuery synchronized with the source database. CDC literally stands for Change Data Capture. It is capturing the changes in your source database and reflecting them in the destination database. As we discussed in the DataStream lesson, DataStream is specifically designed for these replication scenarios. It ensures that changes in your source system are reflected in your data warehouse with minimal latency. You are likely to see one of two patterns show up on the exam. In the first pattern, we start with the source database where all your primary transactions occur. To capture these changes, we use DataStream. This service pulls the change logs from your database and streams them directly into BigQuery. The primary goal here is to ensure that BigQuery stays updated in near real time. This allows your analytical queries to run against the most current version of your operational data by continuously applying incremental updates. The second pattern introduces additional steps after DataStream to make changes to the data before it's loaded into BigQuery. This also begins with the source database and again, we use data stream to capture the initial change events from the source. However, in this workflow, the data is first moved into cloud storage. Once the data lands in a bucket, we bring in data flow. This service picks up the files and processes them before they reach their final destination at BigQuery. This middle stage is used when the data requires extra processing before it is ready for analysis. For instance, you would use this approach to apply transformations such as cleaning, filtering, or reformatting records before they are loaded into BigQuery. This architecture is also necessary when you are combining multiple sources. By landing data in storage and processing it with data flow, you can merge data from various systems and have them unified into a common schema once they reach BigQuery. And that's it for this lesson.